All right, hi everybody. Long time no see. We're going to try this video again. Let me apologize first with the way that this smartphone has to be delivered out to us today. I can't do it horizontally. It just won't work, and I've been having problems with my computer. So we're going to give this a whirl and hope that it'll go okay. We're going to move into 5-4 today. We just finished 5.1, 5.2, 5.3, the three different ways of solving a system. We gave you the homework for that. So now we're moving into 5-4. In 5-4, we're going to apply systems. And when we apply systems, we're going to be looking at a collection of word problems. And these word problems are going to be solved by setting up a system, two equations with two variables, and then we're going to solve them. Now, I sent to you via an email the 7 problems that we're going to cover in here in this section. And so you have all 7 of those. The reason why I did that is because as we look at these 7 problems today, the phone camera is not going to be able to stay fixed on the words of this word problem. It's going to have to go over to the whiteboard to display the process that we're going to show. So that is the reason for giving those word problems to you ahead of time. Now, before we actually get to the first category and the first problem of that category, I want to speak to a little bit about the types of word problems that we're going to be looking at. There's 4 different types that we're going to look at. Number 1, the cost problem. Number 2, the interest problem. Number 3, the mixture problem. And number 4, we'll look at the distance problem. In this first video, we're just going to concentrate on the cost problem. There's one key thing that we want to make sure that gets registered in your mind. The word problems that we'll be looking at in Chapter 5 are going to be structured and written differently than the ones that we saw in Chapter 3. The ones that we did in Chapter 3, here was the unique characteristic about those. In the word problems in Chapter 3, we didn't know any information about one of the unknowns, and we let that unknown be n. But we knew some information about the other unknown or unknowns, and we wrote an expression down about those that we knew something about in terms of the variable n. Let me recreate a scenario that we looked at from Chapter 3. I'll share about 2 of them, just so that you can see what the word problems looked like back then. Number 1, the length of a rectangle is 5 yards more than the width. We didn't know anything about the width. We let the width be n, but we did know something about the length, and we wrote an expression down about the length in terms of that variable n. We only used one variable with that type of word problem because you were given a relationship sentence. The length was 5 yards more than the width. Another, the USA and China problem that we did. The United States won 40 more medals than China. We used one variable to do that kind of a problem. We allowed n to be China, and we allowed the United States to be n plus 40. Why? Because there was a relationship given. But now let's move forward to Chapter 5. The word problems that we're going to see in Chapter 5, we are not going to be given a relationship whatsoever. We're not going to be given any relationship. We're going to be given, instead of a relationship, a total. Now let me just describe a little bit more about that. In the word problems that we're going to be looking at in 5-4, you're not going to be given any information about any one of the unknowns. We won't know any information about any of the unknowns. What we will know is the total number. The total number. And when you don't have any information at all about any of the unknowns, and you're just given the total amount, a system is the best way to solve a problem. So we're going to begin with the cost problem, and we're going to do two of them. Here's number one. Now as I read it, you're going to see that you know absolutely nothing about any of the unknowns. Roses sell for $3 each, and carnations for $1.50 each. We know the price of each type of flower. That's the price. If a mixed bouquet of 20 flowers consisting of roses and carnations costs $39, how many of each type of flower is in the bouquet? Notice the question is asking us to find the number of roses in the bouquet and the number of carnations in the bouquet. But notice in this problem, there was no relationship whatsoever being given to us between the roses and the carnations. The only thing that has been given to us is there are a total of 20 flowers in that bouquet. A total. Because a total has been given to us and no relationship between the roses and carnations has been given to us, but just a total, the best way to solve the problem is by using a system of equations. 2 letters, 2 variables, 2 equations. So I'm going to leave the word problem over there, and we're going to move over to the chart and to the process that we're going to follow. 4-step plan. Step 1. We write a few words that identify what the problem is asking us to find. We need to find the number of roses and carnations that make up that bouquet. We've seen a chart before when we did the interest problem. Here's the chart that's going to be used to do a cost problem. Each column is identified by part of the formula. Here's the formula for finding cost. You take the number of items that you're buying, the number of flowers that are going to be bought, and if we multiply it by the price, in this case, the price of a flower, number multiplied by price will always give you cost. I have the formula written over there in blue. Cost equals number times price. Now on the exam, on a future exam that would be given to you, I will give you this. I'll give you the chart and I'll give you the title of the columns. But I won't give you the title of the rows. The first 2 rows are set aside for the 2 different unknowns that we're dealing with. Roses, carnations. Doesn't matter where you put it. Row number 1, we'll put roses. Row number 2, we'll put the other flower, carnations. Now you see that there is a 3rd row. The 3rd row is entitled by the key word that we gave to you when I was talking to you just moments ago about what the emphasis would be on these word problems. There would be no relationship, but there will be a total. total is the title of the last row. So now let's fill in this chart. The number of flower column. We go to the roses. We don't know anything about the number of roses, so we're going to give it a letter. And people, for the cost problem, I'm not going to be using the letters X and Y. I'm going to be using the letters of which the words begin off with. Roses, I'm going to let the number of roses be R. The number of carnations, we don't know anything about them either. Going to let the carnations be C. But, according to the word problem, we do know this. We know the total number of flowers in the bouquet. And the total number of flowers in the bouquet goes here because the row is entitled total and the column is entitled number of flower. Put the words together, total number of flower, 20. People, we're looking at equation number 1 of our eventual system. Roses plus carnations equal 20. That's going to be equation number 1. I'm not going to write it down yet beside Roman numeral 3, but that's going to be number 1. Let's continue on and finish filling this in. The price of a rose was $3. Now notice when $3 was written in that word problem, it was written without a decimal. We are going to put the decimal in and add 2 zeros. I think that's critical. The price of a carnation was $1.50, $1.50. The total price of flowers, know that nothing goes here. This is empty. Nothing fits there. We go to the last column. Cost of flower. How do we find cost? Number times price. So let's write down the cost of the roses based on what we have right here. Number times price. 3.00R. Same with the carnations. Number times price. 1.50C. And this last box, let's unite the words. The total cost of all of the flowers. The total cost of all of the flowers was $39. We write 39.00. Column number 3 will give us the second equation. Why? Because 3.00R represents the cost of just the roses. 1.50C represents the cost of just the carnations. $39 represents the total cost of all of the flowers of the entire bouquet. So the equation that will be generated from that last column, the cost of the roses plus the cost of the carnations will equal $39. Now let's write our system. Equation number 1, column number 1. R plus C is equal to 20. That's number 1. Number 2, people, so we won't have to do an extra step. This equation is wrapped around decimals. This decimal has 2 digits to the right. This has 2 to the right. That has 2 to the right. They're all in hundredths. We're going to move the decimal points to the right twice in all 3 of those boxes, and then we're going to transfer this equation down here to be our number 2, and we won't have to deal with any decimals. So we're going to multiply each one of these boxes by 100 because they're all in hundredths place. Move the point twice to the right. That's not new. Move it twice to the right, move it twice to the right, and now we're going to write our equation and we won't have any decimals. 300R plus 150 carnation is equal to 3,900. There's number 2. And now we have our system. Just like you saw a system in 5.1, 5.2, and 5.3. Now we solve it. Now here's your option. Don't worry about the graphing method. We're not using the graphing method. We will either use the substitution method to solve this system or the elimination. And as I'm going through these problems with you, I'm going to go back and forth. I'm going to solve some of them using substitution and some of them using elimination so we don't forget the process. On this one, I'm going to elect to use substitution. Equation number 2 is going to stay just as it is because notice, neither of the coefficients of R or C in the second equation is 1 or -1. But equation number 1, the coefficient of R is 1, the coefficient of C is 1. I'm going to leave number 2 right there, but I'm going to take equation number 1 and I'm going to rewrite it about right over here. I'm going to rewrite it. R plus C is equal to 20. Now because the coefficients of either one of those letters is 1, you can solve this equation for C or solve it for R. I'm going to solve it for R. Either one will do. Move that C, get rid of him. Minus C, and we'll have rows is equal to 20 minus carnation, or rows is equal to a -1 carnation plus 20. I'm going to write it in that way. We will eventually come back to him in due time and find the number of roses that are in that bouquet, but we need to substitute first. R is equal to 20 minus C. We're going to substitute that 20 minus C in place of R in this equation number 2. So down, make a house, and inside that house we're going to put what over here it said that R is. 20 minus C, and recopy the rest, plus 150C is equal to 3,900. Now we're going to solve this equation. It's an equation that only contains the variable C. We're going to solve it for the number of carnations. Distribute. 3 times 2 is 6. Add on 1, 2, 3 zeros to that. 300 times a -1C, a -300C. Positive 150C is equal to 3,900. Combine like terms. Bring down the 6,000. A -300C added with a positive 150C. Positive, negative, really subtract. Take the sign of the bigger absolute, which is him. You'll get a -150C is equal to 3,900. Get rid of 6,000, opposite. -6,000 on the left, -6,000 on the right. We'll end up on the left with a -150C, and on the right, a positive 3,900 added with a -600. It's going to be negative because the absolute value of him is negative and he's bigger. And if you subtract 3,900 from 6,000, you're going to get a -2,100. Over -150. Over -150. Bring down the C. Now we're going to get the number of carnations. Negative divided by negative. It better be positive, because you can't have a negative number of carnations. It's positive. People, the numerator ends in a 0. The denominator ends in a 0. I'm going to cancel them off. And off to the side, I'm just going to divide 15 into 210. And we should get our carnations. 15 into 21, once. There's 6 left over. Bring down the 0. it'll go 4 times exactly. 14, label it carnations, circle it, and now let's come over and get our roses. This is the recipe that gets our roses. Roses are equal to 20 minus C. C is 14. 20 minus 14. R is equal to 6 roses. You don't have to put your answers side by side. You don't have to use an ordered pair. Let it stay that way. Put it to bed. It's done. Now that's a cost problem. Okay? Now I'm going to quickly erase because we're going to do a second one. While I'm erasing, the second one is dealing with a movie theater that's going to be showing Superman. And this movie theater has adults that are coming to it and children that are coming to it. And the two unknowns that are going to be dealt with in this problem are the number of tickets that were bought by adults and the number of tickets that were bought by kids. It is the same chart. There's no difference in terms of the chart. I'll just fill in some things when I move over here. But back over here on this side, let's look at it. On the opening night of Superman, the Plaza North Theater sold a total, no relationship, sold a total of 800 tickets. An adult's ticket cost $22 and a child's ticket costs $14.50. In all, $16,640 was taken in for just that one viewing of Superman. Now notice the question. It's not asking for both. It says how many adult tickets were sold. Before I leave this, 800 is a total. There is no relationship between adult and child's tickets. Just like in the roses and carnations, there was a total. There was no relationship. We have the same thing here. So now we'll move over. You can just leave this column number if you want to. You really don't have to write down anything more, but I'll write number of ticket multiplied by price of ticket, cost of ticket. The rows, one of the categories of people that are going are adults, and then children. And folks, total number of adults. We have no idea. Well, then give it an A. Children, we don't know. Know nothing about them. Give it a C. But we do know the total. In that last problem, that was 20. In this one, there was a total of 800 tickets sold. Adult plus child, 800. There's equation 1. Let's move on. The price of an adult ticket was $22. It was written this way in the word problem. You better write it this way. The price for a child, $14.50. Nothing here. It's like a bingo game, free. The cost of the adult tickets, the number, A, times the price, 22.00A. The cost of just the child's number times price, 14.50 C. And the total cost in all, the total receipts that came in from selling all of those 800 tickets, I believe it was $16,640. And folks, here's a key thing. You put a point there and you added 2 zeros. You had to have the point there with the 50 cents. You better believe you need a point there and you add 2 zeros. Don't lose it because of this. This is a key thing. You make sure you put that point in that 0, 0. Now we're going to get those ready. They're all in hundreds. Get rid of those decimals. Twice to the right, twice to the right, twice to the right. Here we go. Equation number 1. Adult plus child equals 800. Number 1. Number 2. 2,200 adult plus 1,450 child is equal to 1,664,000. You don't have to put the commas in there unless you want to. Just make sure you copy things right. There's the system. Now this second go around, I'm going to use elimination. And as we go to using elimination, people, I as well can't emphasize this enough. When you get your system written down, always get your eyes looking up here on step 1. Okay? Step 1, by the way, I better rewrite that. Sorry. Well, we'll get it right now. Step 1, it only asked us to find the number of adult tickets. Number of adult tickets. It's not asking for the number of children. It's only wanting the adult. So if we're going to use elimination, that means we need to eliminate a variable from the system. Well, we don't want to eliminate the A. That's what they want us to find. They don't ask us to find the number of children's tickets, so let's get rid of the C. We'll then have the A, and we'll have our answer. So when we use elimination, go after that LCD. The coefficient of C here is 1. The coefficient is 1450. The LCD between 1 and 1450 is 1450. Now he's a positive 1450. I need to make this coefficient a negative 1450. Tuck, tuck, a negative 1450 on the left, and a negative 1450 on the right. Let's distribute. Negative times positive, a negative 1450A. Negative times positive, a negative 1450C. Negative times positive, a negative. People, I know you have a calculator and you go right ahead and use it. But I don't have one, so I'm going to try to make my multiplication as easy peasy for me. I'm not going to involve the zeros now. I'll involve them at the end. 145 times 8. 40. Carry up the 4. 32 and 4, 36. Carry up the 3. 1160. Add on that 0 and those 2. A total of 3 zeros. 1,160,000. Carry that right over here next to this negative. 1,160,000. Draw the line. Combine these. He's positive, he's negative. You're going to have to subtract. 0. Borrow. 5. Borrow. 750 adult is equal to, he's a positive, he's a negative, he's the bigger absolute. Subtract. 0, 0, 0, 4, 0, 5. over 750. Over 750. Bring down the A over here, knock off the ending zeros. We're going to divide 75 into 50,400. 75 is going to have to divide into 504. You don't need to know your 75s. Now I know the calculator will do it and you use it. But let's just look at the 7. How many times will 7 divide into 50? Well, 7 would go into 57 times, but that answer is 49, and that's so close to 50, I don't think 7 will work. You'll have to carry up, and it's going to be too much. But 6 will work. 6 times 5 is 30, carry up the 3. That's 45. Bring down the 4, borrow. Bring down that 0. 75 into 540. 7 divides into 54 easily 7 times. 7 should work. We'll put a 7 up there. 7 times 5 is 35. 49 and 3 is 52. Borrow. You'll have 15 left over. Bring down that last 0, and 75 will glide into 150 exactly 2 times. 672 adults. He's happy. We're done. Got the answer. Now on that homework assignment that you're going to be getting, there will be 2 cost problems, and they will be done in the same way as this. We'll rejoin you, okay? We'll take a little break, and then we'll move to the second video. Thank you.